In this video, we continue our study of how to express piecewise continuous functions in terms of Heaviside function. In the two past videos, part 1 and part 2, we looked at functions that are defined in two intervals on the real axis. Here we're going to extend these two functions that have got three intervals. So for instance, if you take this function here, if this is your x-axis, it's defined by one function on the left of -2, is defined by another function between -2 and 2, and then it's defined here by yet another function on the right hand side of 2. So in terms of if you like, these functions have got two boundaries which separate three regions. Okay, so how do you express this in terms of the Heaviside function? So there is something we are going to look at first, which is going to help us with these in terms of the Heaviside function. Going to look at the Heaviside function of t minus a minus the Heaviside function of t minus b. In this context, a is strictly less than b. So let's see what happens when we subtract these. So if you imagine, I'm just going to do this in two sketches. If you imagine that this is the point A and this is the point B. So the Heaviside function of t minus a is going to have a step at A, and since t is positive, the step is going to be to the right. Okay, so that's going to be h of t minus a. Now we have just said that b strictly greater than a, so then h of t minus b is going to have a step at b. Again, the step is going to be to the right, so it's going to look something like this. Then what we're going to do now is we are going to subtract. We're going to say the top one minus the bottom one. Now there are going to be three regions where we need to do this. So the first region is the region to the left of A. So in this case, this is 0 and this is 0. So when you subtract the two, you are going to get 0. So this side, we're going to get 0. Then in between A and B, this one is 1. Okay. And this one is 0. So when we subtract, we're going to get 1 minus 0. So that's going to give us 1. And then lastly, the region to the right hand side of B. The first function is 1. The second function is also 1. So when we do subtract, then the thing is going to give us 0. So what happens is we get a box-like function between A and B. So the box is between A and B. Now this function is is such that if you multiply any other function by it, then everything else is going to crumble to 0 except the segments in between a and b. So if you imagine that this is our f of t, for instance, then if g of t is given by f of t times this box, I'm going to call it box, then everything outside this interval is going to become 0. So so this segment is going to become 0. That segment is going to become 0. The only segment that is going to remain is the segment between a and b, because everything else gets multiplied by 0. So our function is going to look something like that. All right, so that is the device we're going to use working with the functions at hand. So let's start off. We have got f of t, which is 0 when t is less than -2, 4 minus t squared when t is between -2 and 2, 0 when t is greater than 2. So if we make a sketch, so this thing is going to be, if we just sketch the parabola 4 minus t squared, it looks something like this. Okay, this point is going to be 2, this point is going to be -2. So what we want is only this section here. All the other sections we want them to go to 0. So that means we need to multiply this by a Heaviside function whose box extends from -2 to 2. So we want a Heaviside function of this nature. And so that means from what we've just done, a is -2, b is 2. So that means the Heaviside function we're talking about is h of t plus 2 minus h of t minus 2. So we take this and multiply into 4 minus t squared. That is now going to give us the function we are looking for. Okay, so that is a. In b, we have got f of t, which again on the left is 0. This is the left of the origin. And then between 0 and 5 pi on 2 is cosine theta. And then on the right of 5 pi on 2, this thing is 0 again. So the first thing we need to do is to make a sketch of cosine between 0 and say 7 pi over 2. So, well, cosine is going to look something like this. This is going to be pi on 2, 3 pi on 2 here, so 5 pi on 2 is there. So the bits of this that we want is only this. So that means we want to hit this with a Heaviside function box, which goes between 0 and 5 pi on 2. So that type of box is going to be given by h of t, because a is 0, minus h of t minus 5 pi over 2. So that means the function we're looking for, f of t, is therefore going to be cosine t times h of t minus h of t minus 5 on 2 pi. So that's going to be our function. All right, at this point, we're going to give you an opportunity to have a go at these last two. If you want to have a go at C and D, you can pause the video and then work through these problems. Then when we press continue, then you can compare with our answers. All right, we're now going to scroll down to our solutions for C and D. We hope that these videos are useful to you. We do implore you to press the subscribe button and subscribe to our channel and like the videos. If you've got any questions or comments, you are free to post them in the comment section below. All right, thank you. So for C, we have got the hyperbolic sine between minus 4 and 4 and 0 everywhere else. Now, the graph of hyperbolic sine is pretty similar to the graph of x cubed, so it goes something like this. So what we want to do in this function, we want to pick the section in between minus 4 and 4, and then everything else is going to become 0. So what this means is that we need a Heaviside box, Heaviside function box, which is going to extend between minus 4 and 4. So our Heaviside function box is going to look something like this. What this means is that it's going to be h of t plus 4 minus h of t minus 4. So that means our function then becomes the hyperbolic sine of t times h of t plus 4 minus h of t minus 4. And for the last question, part D, we have got 2t minus t squared between minus 1 and 2 and 0 everywhere else. So we've got t to t minus t squared between minus 1 and 2, 0 everywhere else, greater than 2. So here, what we're going to do is we're going to make a sketch of the graph of 2t minus t squared. It's going to be a parabola that opens downwards. The two roots are going to be at 0 and 2. So 0 here, 2 here. So this graph is going to look something like this. And then in the case of F, we only want the segments in between 2 and negative 1. So somewhere there. So we just want this segment, and then everything else we want to go to 0. So that means we're going to need a so that's minus 1, that's 2. We want to need a box a Heaviside function box in between -1 and 2. So such a box would be h of t plus 1 minus h of t minus 2. So our function is going to be 2t minus t squared times h of t plus 1 minus h of t minus 2. All right, thank you for watching. It brings us to the end of the video.